We're going to do some more stoichiometry just to make sure you have plenty of examples of it. So remember, we're using mole ratio and molar mass. Mole ratio gets you from moles of one substance to moles of another. That is the coefficient from a balanced equation. And then molar mass gets you from moles to grams or grams to moles of the same substance. And it's just using 1 mole to the formula mass. So you add up the atomic masses. All right, so the first problem says, how many moles of ammonia are produced from 0.6 moles of nitrogen? So we started out with our given, which is a 0.6 moles of nitrogen. And we're going from nitrogen to ammonia, so you know you have to use the mole ratio. Use the mole ratio, your given has to be in moles. So this is already in moles, so we can go ahead and use the mole ratio to relate moles of nitrogen, what we were given, to moles of ammonia, what we want to go to. Okay, so you just look at the coefficients. There's 1 mole of nitrogen. There's nothing in front of it, so that's 1 mole. And then NH3 has 2 moles. The moles of nitrogen mark out leaves you with moles of NH3. And so we are going to take 0.6 times 2 to get the answer, because moles of NH3 are what we wanted. So if you take 0.6 times 2, you're going to get 1.2 moles of NH3. Okay, the next one says calculate the number of grams of NH3 produced by 5.4 moles of hydrogen gas. So the 5.4 moles of H2 is our given, and we want to go to grams of NH3. So all right, so our given's already in moles, so we can use the mole ratio to go from moles of hydrogen to moles of what we want to go to, which is NH3. And that's going to be the coefficient in the equation. So the hydrogen has 3 moles, NH3 has 2. So we're going to put 3 here and 2 there. We'll mark the moles of hydrogen out. They're diagonal from each other. They'll mark out. That leaves you with moles of NH3. Then we wanted grams of NH3. So now we're going to use molar mass to convert moles of NH3 into grams of NH3. Okay, and remember, molar mass is always 1 mole, and it doesn't matter if the moles are on top or bottom. You just want them to line up diagonally so they'll mark out. So we've got the 1 mole of NH3 here, and to find this, we're going to add up the atomic masses of nitrogen and 3 hydrogen. Nitrogen is 14, and then there's 3 hydrogen. Hydrogen is 1.01, so that'll be 3.03 plus 14. So the atomic mass is 17.03. If you don't know where I got those numbers, it's from the periodic table. Hydrogen's atomic mass is 1.01, nitrogen is 14. So we just added up 1 nitrogen, 3 hydrogen. Okay, so the moles of NH3 mark out, and that leaves us with grams of NH3, and that's what we wanted. So now we're going to take 5.4 times 2 times 17 and divide it by 3. So if we do 5.4 times 2 times 17.03 and get that number and divide it by 3, that comes out to be 61.308 grams of NH3. So that is your answer for that one. All right, so the next one says calculate the number of grams of NH3 produced by 5.4 grams of hydrogen. So we're going to start out with our given, which is 5.4 grams of hydrogen. And it wants grams of NH3. Remember I told you in the other one, the other video, that grams to grams is your longest one. The first thing you have to do is use molar mass to convert your given into moles. So we're going to convert grams of H2 into moles of H2. We are doing this because we have to use mole ratio to convert from hydrogen to NH3. So grams of H2 would be 2.02. We added up the atomic masses. There's 2 hydrogen, and the hydrogen's atomic mass is 1.01. So now we're going to use the mole ratio to convert moles of H2. Remember, we want them to line up diagonally to moles of what we want to go to, which is NH3. All right, grams of H2 mark out. We're going to get these numbers from the equation. There's 3 moles of H2 and 2 moles of NH3. The moles of H2 mark out when they're diagonal from each other. And that left us with moles of NH3, but we wanted grams of NH3. So we're going to use molar mass again to get from moles of NH3 to grams of NH3. I put the moles on the bottom because I needed it to be diagonal so it would mark out. And now we're going to add up the atomic mass. We already found the atomic mass up here, so I'm just going to use that number again, 17.03. Or the formula mass, not atomic mass. We added up the atomic masses to get this formula mass. So now moles of NH3 mark out. That leaves you with grams of NH3. So to solve this, we're going to take 5.4 times 2 times 17.03 divided by 2.02 times 3. All right, so we're going to do 5.4 times 2 times 17.03 in the parentheses divided by, do parentheses for this, 2.02 times 3 and in those parentheses. And that comes out to be 30.35 grams of NH3. Right, so let's move on to the next set. We've got our balanced equation. Always check to see if your equation is balanced first. So this says how many moles of sulfur trioxide are produced when 20.2 grams of FeS2 react. So sulfur trioxide would be the SO3. It's using the prefixes, so the tri means 3 oxygens. So we're going to start out with the 2.02 grams of FeS2. And we're going to moles of sulfur trioxide. So if we're going from moles of one substance to another, we have to use mole ratio. To use mole ratio, your given has to be in moles. So the first thing we're going to do is use molar mass to convert grams of FeS2 into moles. So our 1 mole will be up here on the top. Grams will be on the bottom. We're going to add up the atomic masses to find this number. So if we look on our periodic table, iron is here. Okay, and its atomic mass is 55.85. And then we're going to add up the mass of 2 sulfur. Sulfur's right here. So there's 2 of those. Oh, there's kind of a glare. So the sulfur has an atomic mass of 32 if you look at it, which you can't really see it on here, but it's 32.064. 32 is fine. So we're going to do 2 times 32, and that gives us 119.85. Okay, so the grams of iron sulfide mark out. That leaves us with moles of iron sulfide, but we wanted moles of sulfur trioxide. So we're going to use the mole ratio to go from moles of FeS2 to moles of what we wanted to go to, which was sulfur trioxide. We're going to look at the coefficients to get these numbers. FeS2 has 4, so we're going to put a 4 there. SO3 has 8, so we're going to put an 8 there. The moles of FeS2 mark out. That leaves you with moles of sulfur trioxide. That is what we wanted, moles of sulfur trioxide. So to solve this, we're going to take 20.2 times 8 and divide that by 119.85 times 4. Okay, so 20.2 times 8 divided by 119.85 times 4. 0.337. And that is moles of SO3. And just get in a habit, if you've got a decimal, start putting a 0 in front of it. Sometimes that decimal gets lost if you don't, so it's easier just to go ahead and put the 0.333 or 337. All right, the next one. How many moles of SO3 are produced by 2.3 moles of FeS? So we're going to start out with our given. 2.3 moles of FeS2. And we want moles of SO3. This is already in moles, so we can go ahead and use the mole ratio to get from moles of FeS2 to moles of SO3. We're just going to compare the coefficients in the equation. FeS2 has 4, SO3 has 8. So to solve this, we're going to take 2.3 times 8 and divide that by 4. So the answer comes out to be 4.6 moles of SO3. Okay. And then the last one says, how many grams of oxygen are needed to produce 25 grams of FeO2? Remember I told you grams to grams is the longest one. So we're going to start out with 25 grams of Fe2O3. First thing we're going to have to do is convert grams of Fe2O3 to moles using molar mass. We're going to add up those atomic masses to get this number. Iron's atomic mass is 55.85. So we're going to do 55.85 times 2 plus oxygen's atomic mass is 16. There's 3 of those times 3. And that comes out to be 159.7. So the grams of iron oxide mark out. That leaves you with moles of iron oxide. So now we're going to go from moles of Fe2O3 to moles of what we wanted to go to, which is oxygen. We're going to use the mole ratio for that. So we're going to look at the coefficients in the equation. Fe2O3 has 2. So it's got 2 moles. Oxygen has 15 moles in it. Moles of Fe2O3 mark out. That leaves us with moles of O2, but we wanted grams. So the next thing we're going to do is use molar mass to change moles of O2 into grams of O2. Oxygen 16, there's 2 of those, so that's 32. So to solve this, we're going to take 25 times 15 times 32. 25 times 15 times 32, and we're going to divide that by 159.7 times 2. So that comes out to be 37.57 grams of O2.